Hello everybody, in this video we're going to talk about how to graph a quadratic inequality in two variables. So we have a y and we have an x. So we're going to think about how we did this with with inequalities when we did linear functions, and essentially we're going to follow the same steps. So if we look on the left side of our screen here, we have the different options that we could be presented with. And notice the difference here is just basically our sign, right? So less than or equal, greater than or equal, or greater than. And so our equation, since we're talking about a quadratic or our inequality, is ax squared plus bx plus c. That's our standard form for our quadratic. And so remember, we could graph our equations with a dashed or a solid line, just depending on what type of inequality symbol we have. And that's what we have right here. So dashed would be for when we have a less than or a greater than, right? No equals sign there. And solid lines would be if we have or equal to, right? So we're talking about a quadratic here, so that's our parabola. So if we have a dashed line, it would be or a dashed parabola, it would be if we have less than or greater than, solid parabola if we have or equal to, okay? On the right side of our screen, we see our steps, and this is essentially just what we did for a linear inequality. We're going to graph the parabola with the equation y equals ax squared plus bx plus c, so we can just follow how do we graph a quadratic in standard form. So I'll link that in the cards right now. For step 2, we're going to test a point inside the parabola to see if it is a solution of the inequality. Now, that says inside. Could you test a solution on the outside of the parabola? Sure. Just wherever your solution lies, if it's true, that's where you're going to shade. So that brings us to step 3. If step 2 is a solution, shade inside the parabola. Now, once again, if you chose a point outside the parabola and it was true, you would shade outside. If step 2 is not a solution, you shade outside the parabola. So just like with a linear function, if we chose a point on either side of the line, wherever that point is true, if it's a solution, we shade there. If it's not a solution, we shade on the opposite side. So we have one example to look at in this video, and we're going to graph y is greater than negative x squared minus 2x plus 15. So the first thing we're going to do is graph our parabola. So we're going to start off by finding the axis of symmetry, and that is equal to opposite of b over 2a. So right now b is negative 2, so opposite of b would be 2, and a is negative 1. So this is going to be 2 divided by negative 2, which is negative 1. And so now we can put our axis of symmetry right here, and I'm going to make this a dashed line. So now we can use negative 1 to find our vertex. So we can say negative, and then negative 1 squared minus 2 times negative 1 plus 15. So this would be negative 1 plus 2 plus 15, and that's going to be 16. So our vertex of our parabola is going to be at negative 1 comma 16. And we'll put that right there. Now we do know that the y-intercept is our c value, so that would be 15. And we could plot that right there, and we can reflect that point over. Now we can draw our parabola through these points, but we can add some more just to make it easier for us to draw. Now if we notice here, we don't have a stretch or a shrink, so we could think about the relation that our other points in our parabola have with the vertex. So the 2 points that we've graphed here, they're like 1 out and 1 down because we did have a reflection. So the next couple points would be 2 out and 1, 2, 3, 4 down, right? So it would be like those two. And then 1, 2, 3 out and 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So that'd be good right there, right? And so now we can try and draw our parabola here. Let me see if I can get it to stick. Good, and then I'll adjust kind of where everything needs to go, okay? All right, left side looks pretty good. Let me adjust this right side a little bit. And I think that's pretty good. Let me go up with the vertex a little bit more, good. And now let's see if it'll let me make this a dashed parabola. Perfect, right? So we know it needs to be dashed because we just had our greater than symbol. So let me put some arrows on the end of this. So there's our graph, right? So now I'm going to take away my axis of symmetry because we don't really need that anymore. And so now we've graphed our quadratic, and now we need to pick a test point. Now, just like with linear inequalities, the origin is probably the easiest test point to use, right? Because we're just plugging in 0, 0. So in this case, I'm going to use the origin. Notice that that is inside my parabola. So if my equation or my inequality was y is greater than negative x squared minus 2x plus 15, I'm going to use the origin as my test point. So I'm going to plug in 0 for y, and I'm going to plug in 0 for x. Okay, and I just solve this. So I get 0 is greater than, that's going to be 0, that's going to be 0, and we get 15. Is 0 greater than 15? the answer to that would be no. So since my origin was on the inside of my parabola, I'm going to shade the outside. So now my solutions would be anything that is on the outside of our parabola like this. Okay, so we can shade that part, and then we can shade over here as well. Okay, so just remember with inequalities when we're graphing in a coordinate plane that there's going to be some shading involved, and so that could be a helpful reminder so that we make sure we graph the correct inequality. Okay, and that's how you can graph a quadratic inequality.